Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, my friend, to my YouTube channel, Drilling and Workover. My name is Abdelaziz Gabr. I am accredited instructor in IWCF well control and IADC well sharp. Also, I am accredited instructor in IADC mod engineering for basic and advanced mod school. Today, inshallah, we will continue to talk about the course of advanced mod school. And inshallah, we will continue about the very vital object or very vital session that we are talking about. It's about the solid control equipment. In the last lesson, we have talked about the shell shaker in general and about its shape, its configuration, about the parts. And today, inshallah, we will talk about very important thing, which is about the screen engineering or about the screens of the shell shaker, and also about some operation of the shell shaker and how to make an evaluation for the shell shaker to be sure that everything is going in the right way. So please today, every word I will say, please take a note about it. It will be very useful session, inshallah. So, sorry, this is the solid control, as I have told you before. And now we will continue about talking about the shell shaker. Today, as you see, this is the shaker screen. From the first, we need to talk just a little bit about the shaker screens. Shaker screens, they are screens, okay, like the sieving at your home. If you see that your mother or your wife is getting the floor, okay, and make sieving for the floor. So the fine one is coming from the sieve, but the more coarse one or the coarser one remains over the this sieve, so that this is the same like the screens that we are using for the solids and the mud. So take care that this graph, okay, this graph, here the particle size in microns, okay, and here the particles removed by the screens. So here, this is the microns in, so there is very important thing that we will talk about. It's called the, sorry, D cut point, okay? What is the meaning of D cut point? Every screen, okay, every screen like this, all these are screens, okay? This is, for example, the API 10, class 10, API 12, API 14, API 30, API 40, all these are screens, okay? Every screen of them has its characteristic curve. This characteristic curve has some points. The most important one is here D0 and here the D100. So what is the meaning by D0 and D100? This means that the amount or the size, or this refers to the size in microns that can be separated by the screen. So if you say that, for example, D60 here for example API class 10, the D60 is plus or minus 1000 micron. So what is the meaning? This means that if you put these screens on the shell shaker, when the solids, okay, comes with the size, with different sizes, okay, all the sizes less than 1000, okay, less than 1000 will pass through the screen, but at 1000, okay, at different, okay, for sure at different percent, but 1000 will be separated by 60%, and only 40 will pass through the screen. And if you go to, for example, to D100, it will be about here, for example, 3000 or something like this. So this means that all the solid, or all the size above the 3000 will be separated by 100%. So there is no problem about this. So we will talk about it in details now about the screen engineering. Okay. As you see here from the graph, okay, this is for example, this is for ABI 70. This is its own graph or its special graph, okay. Here, as you see, this is the particle and this is the particle size, and here's the percentage to be removed, very important point. Here, for example, the D50, okay, which was used D50 was used before, okay, but now it is obsolete, and the only one used is the D100 in making the labeling for the screens, okay, and we will know about all these notes inshallah. Okay, this is the for example here 90% of the solids at 58 micron, for example here, okay, at 58 are removed. So when I say the D-cut point, this means the size to be removed by the person that is denoted on the below the D or subscript D. Okay. Some definitions about the screen. Okay, this is the screen. Okay, or this is the screen as seen under the microscope. So this is very important. There is something is called wrap and width. Okay, what is the meaning of wrap? The wrap are the wires running lengthwise in the cloth as woven. Okay, and what's the meaning by width here? Okay, this wires running crosswise in the cloth as woven. Okay, here there is very important definition. It's called the mesh count. For example, if I say that ABI 70 equal, for example, 100 mesh, or its mesh is 100. Okay, what's the meaning by this? This means that the linear inch, okay, the length of the inch or the linear inch has number of apertures equal to the 100. So the mesh number or the mesh count or n equal the number of apertures or holes, for example, per linear inch measured from the center of one wire to a point 1 inch to a point 1 inch, okay, distance. What's the meaning of pitch? Pitch here is the distance between the centers of the two adjacent wires. For example, here from here to here, it's called the pitch. Okay. What is the meaning by open area? For example here, if you see this screen, okay, you will see that the screen has some, for example here, plastic. Why this plastic is acts as a support? Because for example, if you see the length of the shell shaker, it can give you an area of, for example, 2 meters, 2 meters squares. So if you make the wires without supports in the bottom, or without supports in the middle of them, it will be torn. Torn rapidly. But we are making a unit area. Okay, for example, a unit here. Then we make some plastic support. Then another unit here. Then another unit, and repeat them again. So the open area is the only apertures here. Okay, so it is the fractional open surface area of the wire clothing from flow directional. Okay, so this is the open area in sense in the screen. Okay, take notes about this, because this is the open area. Because there is another definition that we will talk. It's called non-planked area. Okay, there are two different definitions. The first definition is the open area, but the non-blanket area we will talk about it inshallah later. Okay. Some definition. What's the meaning of mesh? As I told you, it is the number of opening per linear inch. Take care, it is not per square inch, but per linear inch. Okay. Okay, whether a square, for example, 30 divided 30 or oblong 70 30 or something like this. The D cut point, it's a combination of micron size, as I told you, and percent of the size removed, of that size removed, okay? There is something is called D50 cut point for example, the D50 cut point for 40 micron size particle screen. It means that 50% of this micron screen or this 40 micron size particles have been removed and 50% has been returned to the system, and this was as per API recommended practice 13E. 13E. What about the D100 cut point of the screen? It means that the particle size at which no particles will pass, okay, through the screen, and it is as per API recommended practice, recommended practice 13C. Okay. Now, what is the meaning by API screen number? For example, I say this is API 170, API 100, API 70. What is the meaning? Actually, in USA, there is very important thing like the API, okay, but this is for the material. It's called ASTM, which means the American Society of the of the Technology and Material. ASTM. This is a definition, or this is an abbreviation of American Society of Technology and Material. So they put the rules about everything and everything concerning the material, okay, or metals or something like that. So from the material there are the screens, okay, and when I say this screen is labeled as API 170, this means that they have made tests for it and they make it with this label. But to give you more details about it, it is determined by a specific test, okay, done by the ASTM. It determines the D100 cut point for screen and compare it to the D100 of the test done by the ASTM. And so they put the label, for example, this is API 170, this is API 100, and something like this. So the test uses a specifically graded sample of aluminum oxide. Okay, so the test is done by the graded sample of aluminum oxide, which is passed through a stack of sieves. There are a stack of sieves, okay, including the test sieve, and mounted in a Tyler RO tab. And we will see this, inshallah, in the other slide. Okay, there is another definition. It's called screen conductance. What's the meaning of screen conductance? It means it's about using a Newtonian fluid. Take care about this. Newtonian fluid like water. Okay, we will talk about all this hydraulics, inshallah. But Newtonian fluid like water, for example, like diesel, it's a fluid without solid, for example. It's about the Newtonian fluid ability to flow in unit area of the screen. So this is the conductance. The more the conductance number, the higher the flow. Another definition, it's called the non-blanked area, which is the net unplugged area in the screen available for the fluid to flow. And we have to distinguish between the non-blanked area and the open area in the screen, because this is very important. And this is for D50 as you see here, this is for D100 as you see also here. And as I told you, the D cut point, everything, every solid control, every screen, every hydrocyclone, desander, desilter, centrifuge, every solid control has its own API D curve and has its own D cut point. Okay, so this is very important. The API screen number determination. Okay, how can or how is the API screen number determined? Okay, For example, the recommended practice 13C describes a method to define and compare the absolute D100 separation. Absolute means D100 separation potential of any shaker screen as per to the ASTM standard test device. As I told you, the ASTM has made a standard test device, and in the next slide you will see the numbers. Okay, and once we make a screen, for example, we are comparing the result, okay, the result done on the screen by the result or that have been already done by the ASTM in the manuals. So we put or we give them the number that we need. Representative section of the screen is mounted in a holder and is placed in the middle of a stack ASTM device calibrated according to the ASTM E11. Okay, you will see if you need, for example, about the test, we put a holder and put the screen in it, and we are putting the graded using RO tab defined an amount of graded aluminum oxide in the sieve, and the result is collected and graphed, and it can be repeated 3 times, and the average is taken from the test to determine the D100 cut point. Then we compare it to the ASTM standard table. As you see here, this is the holder, okay, and okay, this is the test of the screen mounted in the holder. This is the holder and this is the screen, okay, we put it inside it. And as you see here, this is the stack, okay, this is the stack of the RO tab. This is our RO tab with the test screen and the CV stack, and we put here the aluminum graded or the graded aluminum oxide. And after that we can see how about the microsigns, that the microns that have passed from here and the others that is not passing, and we can compare it to this table. Okay, this is the table has been done by the ASTM. For example, the D100, if it is, for example, here more than 98 micron to 116.5. So this is the API 140. Okay, so take care about this, very important in order to make labeling for the screens. Actually, here, what is the difference between D50 and D100? And why we use the we were using the D50, but now we are using the D100. Actually, by making a lot of experiments, we saw that the D50 for too much screens, okay, for a lot of screens may give the same D50, as you see here. For example, the ASTM 2 mesh sieve, okay, here give the same D50 as API 140 and also the same D50 as 100. So we cannot distinguish well about the D50, and it was used already by the API recommended practice 13E. But in the new update of the API, it is about the API recommended practice 13C. It is used the only used is the D100. It is the most common used, and the D50 becomes obsolete or it is not used. Okay, so we are comparing now with only the D50, and it was in the last or in the API recommended practice before. We were using the D50 and the for example D84 and D16 in order to use too much. Okay, we were using too much data in order to be sure that this is the screen or this is the right label for the screen. But now the only used is the D100, and if you are seeing the labeling of the screen, you will notice it is just D100 microns to be used. So no, it is not a big problem. Okay, now what is the difference between the mesh and the API? For example, when I say the API equal 170, okay, but the mesh equal 200. The same API 170 for another country, for another company gives 230. For third company give us 233. For example, a different number. So where is the difference between them? Actually, the number of mesh depends on the apertures per linear inch. Okay, but the API it's about the micron size, the micro size, micron size, or the size on in microns that is separated. Okay, so the API is the micron size to be separated, but the mesh is the number of apertures. Okay, so for example, a company like MI, okay, has API 170, for example, which means D100 equal 74. Okay, all the API 170, its micro size to be or its D100 equal 47. Okay, there is no problem, but it depends what the mesh depends is different from another company to another company. It depends on the wires diameter of the screen. It depends on the wire diameters of the screen. So some companies, for example, some companies are using very fine wire, but from strong material, so it can live for a long time. Another companies are using thick wire, but it can't live for a long time, or to have a good screen, good life for screen, or good screen life. So this is the main difference between the mesh and the API. Okay, so that it is different from a company to another company, and as I told you, it depends on the wire diameter of each screen. As you see, this is different than this, than this, and as you see, for example, here this is labeled 200 mesh. Okay, and this is labeled 200 mesh, but this is API is 60 and this is API 200. Okay, so but for example, if you use the API 80, it is the same micron as you see here. Okay, here also API 80, it is the same micron as you see here. Okay, but it's labeled as 175 mesh, but this is 180 mesh. As I told you, it depends on the thick, on the how the wire is thick or how it is fine. Some shaker operation to select the screen size. How we select the screen size? Actually, the finest available mesh should be fitted, but take care that the screen or the flow over the screen or the pool must not be more than 70%. Okay, so the finest available mesh should be fitted, which can be run without loss of the whole mud from the front of the screens. As a general rule, the back, okay, the back 2/3 or 2 3/4, for example, it's about 75% of the screen should be covered with mud, no more than this. Some shaker operation, sometimes there is a blinding or screen blind which may happen to the screens. Blinding. What is the screen blind? It's caused by a reduction in the fluid transmission capability of the screens, which leads to whole mud over the screen losses. As you see here, this is the blinding. How the blinding happened? Maybe some cement happened, maybe a lot of solids, due to a lot of solids, maybe due to a lot of problems. Number two, coating. What's the meaning by coating? The coating of the screen wires by dried or sticky solids can happen. The coating, when you are drilling sticky solids, you will see a lot of coating happen. This reduces the aperture sizes and can drastically reduce the screen's conductance. Screens should always be thoroughly washed down with a pressure wash gun. Okay, if the shakers are to be turned off for a period of time. So as I told you, if you need to clean the shell shakers, you have to use the pressure wash gun. Number B, from the shaker operation, it's called the plugging. Plugging, as the name suggests, this problem occurs due to the plugging of the screen apertures by particles about the same size, so that often referred to as near-sized particles. So the plugging happened when the size of the solids is nearly the same for the apertures, so that the plugging happens like this. For example, this is also a plugging, this is also a plugging, this is also plugging. All these are plugging for the screen. So the most common one for to have to make the most common case for the screen plugging is for the sand particles, which becomes tightly wedged in the screen opening. Also, number two is the greasing problem. What is the meaning? What is meaning by greasing problem? Actually, the greasing problem happens when salt mud with high calcium and high percentage of lubricant. Okay, so if you have high calcium and a high percent of lubricant, you are liable to the problem of greasing, and you will see a lot of grease. Okay, a lot of the lubricant will become grease on the shaker, and so that it will make or it will make plugging for the screen or blinding for the screen due to this problem. So you have to reduce the calcium and to use the wash gun in order to avoid this problem, because the greasing problem can lead to damage the screen and not able to be used again, and also it can lead to a lot of losses for the mud or overflow from the shakers. Number three, high sand content. Number three is the high sand content. Number four is the high percent of low gravity solids. Number five is the drilling salt. Also, it can lead to the plugging. The shaker vibration or variables and adjustment, you have to take care about this. Number one is the vibration energy. It increases the capacity and dryness of the solids. Also, it decreases the screen life. Also, the deck angle, you have to take care about both of them, the vibration energy and, for example, the RPM, okay, and the deck angle. It affects on the retention of the solids over the screen. So it affects the retention and also the pooling and the concentration. So it has to be no more than 3 degrees for the deck angle. So take care of this, because those are both the most controlling parameters for the screen or for the shakers. Number one is the vibration energy. Number two is the deck angle. Alert to the mod engineers. Take care as a mod engineer from these coming points. Number one, the share screen must be checked daily. Okay, and any torn, immediately you have to change it. Number two, the shaker screens must be suitable for the flow rate used in the drilling, and you have to know that if you are in the surface hole or if you are in the intermediate section or in the bay zone. So you have to take care about this, and you have to make optimization between the flow rate and the screen to be used, or the API screen to be used. Number three, during changing the screens, don't permit to anybody on the rig floor or on the rig crew to stand over the screen. Why? Because this will increase the holes and decrease or the apertures, for example, and decrease its efficiency in separation. At the beginning of the drilling, use a small mesh size. Small mesh size is used to avoid the overflow of the shaker. And after this, when the mud has been sheared, you have to use another finer one. So it is better to use finer one. During oil-based mud also, begin with a small mesh size to avoid the separation of the chemicals on the shell shaker before shearing. Now, how to evaluate the shakers and screen? How you can evaluate this that the shaker is working properly? Okay, number one, check the air supply for the rubber insulation on the screens to be 90 psi. This is very important for the isolation and in order not to permit the solids to escape from the side below the rubber. Number two, check for the rubber strips for cushion screen and they are in good conditions. Okay. Number three, check for the three-phase motors to work properly, and you have to see the certificate of those vibrators and motors because, for example, at 60 hertz, they are working with RPM 1800. So you have to have a certificate of inspection about this. It's very important one. Check for the motors to have the right RPM for making good vibration. Okay. Check for the counterweight inside the motors. Okay. To be in different directions to make a linear motion. This is very important one because at sometimes you see that the cutting are not going out from the shaker, but they are going inside the shell shaker. So how to use this? At first, you have to check about the three phases of the motor, and you can change any one by the other one in order to get the right direction. Also, you have to make to remove the cover of the motor, and see the counterweight. They have to be working in different directions, one to the right and the other one to the left, in order to make a balanced linear motion. Okay. Check for the certificate of the maintenance of the shaker and its original certificates from the contract. This is very important. Check for the G-force by the simple method as the stroke detector, as I have told you in the last session, or by a specialized device for the equipment. Okay. Check for the direction of the flow to be in the middle of the screens, not on the sides, in order to decrease the horse show effect. How to evaluate also the shell shaker? There are some practical suggestions for the shell shaker. When changing the screens, clean the tension rails that hold the screen and lubricate the tension bolts so that they can be torqued up properly. Number two, wash the screens when the machine is shut down and retention the screen every day or so. Retention of the screen every few hours after the initial installation. This is very important. Why? Because this tension is very important because the solids can make some, or the solids or the mud with its temperature can lead to some thermal expansion, which may make the apertures to be more than the required. So you have to make the tension from time to time, or to check about the tension of the screens from time to time. Number three or number four or the next number, the bypass gate of the shell shaker should never be opened during the normal drilling, even in trips, but it is only used when some cement is coming during the cement displacement, in order to get all the flow of the cement overboard, in order not to make a problem for the screens and for the shell shaker. The bypass is intended to be used only for discharging the mud when it is contaminated with cement. When using a shell shaker to separate solids for the salt, water, or high concentration KCl, use a spray small amount of water on the screen so that the salt will not precipitate on the screen and plug it. Uh, Thank you very much today for this very important lesson. And I hope, inshallah, to give you another lesson about the sand screening and shell shaker. Thank you today for very good, and this is very good lesson, inshallah, today. See you tomorrow, inshallah. If this video appeals to you, share. like, subscribe. It's your channel, not mine. And see you later, inshallah. Thank you very much and goodbye.